Hello, friends. Today we are going to study about the internal structure of Dicotyledon root. For example, the typical examples of the dicot root we can visualize the root of sunflower, the root of gram, root of pisum, pea. These are the typical examples which shows dicotyledonous internal structure. Now we have to study what type of vascular bundles are present in the root, how they are organized, what are the different components and other structures related to the internal structure of the dicotyledon root. Now over here, this is the structure of dicot root which have cut it in the transverse section, the DS of dicot root. Now, if you observe the sector of the root, the sector shows from the periphery up to the core part of the root. For example, over here, this is the outer part of the root, we call it as epidermis, and this is the core part of the root, central part of the root. So this much section out of round ground plan, this is enough to describe how internally the different layers in the root they are organized. So this is the enlarged section of the total complete round section, diagrammatic ground plan. This is the sector which we have enlarged, magnified over here to observe the different layers composing internally the root. Now this particular root shows the outermost covering, we call it as epiblema over here. We call it as epiblema over here. Epiblema means it is the epidermis, it is the skin of outermost skin of the root. We can call it as epiblema or epidermis, or some people call it as a piliferous layer, showing the pili or the root hairs developed from the epidermal cells. For example, over here, these are the root hairs which are developed from the epidermal cells. The root hairs are helpful for absorption of water and minerals from the soil. So these are the absorptive structures developed from the epidermal cells. These are the absorptive structures developed from the epidermal cells which are helpful for absorption of dissolved nutrients present in the gravitational water. Now, beside this is the outermost skin. It performs the function of protection. So, in addition to the protection as the principal function, this particular outermost covering epiblema performs the function of absorption of water with the help of the root hairs developed from the epidermal cells. This particular epidermis is made up of barrel-shaped cells which are compactly placed, compactly arranged, forming a protective coat coverage around the root. So this is the protective function of the epidermis. Now this particular epidermis thus serves the function of protection as well as it absorbs the dissolved nutrients and water from the medium where the plant is growing, that is from the soil. So absorption of dissolved nutrients, minerals from the soil and water, this is the absorptive structure. Now this particular epidermis is not provided with the cuticle over here as it performs the function of absorption. Just like the stems, there was a cuticle around the epidermis. Over here, this particular section shows no cuticle. Cuticle is absent over here. So this is all about epidermis. Now some people called it as piliferous layer. Pili means the hairs. Flagella like hairs. Now some people call flagella as pili. Over here, just like the pili or flagella, here there are the unicellular root hairs. So therefore, due to the presence of the unicellular hairs or pili, this particular epidermis is also called as piliferous layer or epiplema, or we can simply call it as epidermis, outermost skin, protective skin, absorptive skin of the root. Now below this epidermis, there is a region of cortex. Now these are the parenchyma cells. Now this is the outer part of the cortex. This is the inner part of the cortex. This cortex part is made up of loosely fleshed, soft, delicate parenchymatous type of tissue, which is a storage tissue composing the cortex part of the root. This is a massive region, thick region composing the large storage part of the root, with numerous intercellular spaces between the cells. So this is the cortex made up of parenchyma type of tissue. Now the lowermost region of the cortex is called endodermis. The lowermost region is called as endodermis. Endo means innermost or lowermost. Dermis means a skin, or dermis means a layer. Innermost layer of the cortex is called endodermis. Innermost layer of the cortex is called as the endodermis. Now, this endodermis is helpful in absorption of water. This endodermis is helpful in the process of absorption of water. The water absorbed by the root hairs. To passage this particular absorbed water, the endodermal cells are helpful. Now, below the endodermis, there is a pericycle. This is a pericycle over here. Inside the region of endodermis, this is endodermis, and the inner layer is a pericycle. So there is a circle, or there is a uniseriate circle of the parenchymatous cells composing the pericycle around the vascular bundles, around the xylem and phloem, which is a conducting tissue. Around this conducting tissue, the pericycle is present. This is the pericycle, and this is present around the xylem and phloem. This surrounds, therefore we can call it as a pericycle around the conducting elements, the parenchymatous unicellular parenchymatous, one row of the cells composes the pericycle, and it surrounds the conducting strands, xylem and phloem, which are located inside it. Now, the core part of the root is the vascular part, where there is a xylem, there is a phloem over here. There in the roots, the xylem and phloem composes the vascular bundles of very characteristic type. Not like the stem. Here, the vascular bundles are different. There is a xylem patch over here. For example, this is a xylem patch, this is a xylem patch, this is a xylem patch, or this is a xylem patch. So, xylem is present in the form of patches or bundles. Just like the bundles of the xylem or patches of the xylem, phloem is also present in the patch. This is one phloem bundle or patch. This is second phloem bundle, third phloem bundle, fourth phloem bundle. So phloem is also present in the form of the patches. Now if you observe these xylem and phloem bundles or the patches, these xylem and phloem bundles or patches, they are present on different radii. Xylem on this radius, phloem on this radius, succeeding xylem on this radius, phloem on this radius. Succeedingly, xylem on this radius, phloem on this radius, xylem on this radius, phloem on this radius. So due to such a characteristic occurrence of xylem and phloem on different radii, the vascular bundles there in the root are called radial type. The vascular bundles are called as the vascular bundles of the radial type. Vascular bundles are called as the vascular bundles of the radial type, where the vascular bundles are arranged on different radii. The xylem and phloem bundles are arranged on the different radii. Vascular bundles are called radial. So this is how these radial vascular bundles are different from the vascular bundles of the stem. In the stem, they were conjoint and collateral. Xylem and phloem was jointed in one bundle there in the stem. Therefore, we call there as conjoint and collateral. Over here, the xylem bundles are separate, the phloem bundles are separate, and therefore, such vascular bundles where the xylem and phloem bundles are present on different radii, the vascular bundles are said to be of radial type. Vascular bundles are said to be of radial type. Now, if you observe the structure of xylem, the larger xylem element, suppose this is the larger xylem element, this is called as metaxylem, and this is called as protoxylem. The protoxylems are the smaller xylem elements. The protoxylem points are facing toward the peripheral side or toward the outer side, and due to such a occurrence of protoxylem point toward the periphery, toward the exterior part, outer part, this is protoxylem over here, protoxylem over here, this is protoxylem over here. These protoxylems are located away from the pith. This is the pith part. In the center there is a pith. Away from this pith, away from the central pith, the protoxylem points are located over here. The protoxylem points are located. Now, such a location of the protoxylem points toward the peripheral side, such arrangement is called as X arch. It is called as X arch. X means toward the outer side. Arch means the protoxylem points. The protoxylem points are facing or they are located away from the center, away from the pith, toward the peripheral part, toward the outer part. So the vascular bundles, the xylem is said to be X arch. X means outer, arch means the protoxylem points. Smaller xylem elements, protoxylem points are facing toward the periphery, toward the outer side. And in the central part, there is the pith. There is a parenchymatous pith. There is a little quantity of parenchymatous pith is present there in the central part of the root. Now, if you observe the total number of vascular bundles, total number of radial vascular bundles present in the stem, they measures average in dicotyledons from 2 to 4 in number. Now, over here, this particular figure shows 1, 2, 3, 4. 4 xylem bundles and 4 phloem bundles. So this is called as a tetrarch type of the root. Tetra means 4. 4 radial vascular bundles are present. Therefore, it is called as tetrarch type of the root or tetrarch type of internal structure. Now there are certain dicots which may show 2 radial vascular bundles. Some they show 3 radial vascular bundles. So in dicotyledonous root, the total number of radial vascular bundles are from 2 to 4 in number. That is diarch 2, tetrarch type of the internal structure is seen in the dicotyledonous roots. So this should be remembered that there are minimum 2 radial vascular bundles or maximum there are 4 radial vascular bundles, and the structure is said to be diarch to tetrarch in the dicotyledonous roots. For example, sunflower, pea, gram. In these roots there is a diarch to tetrarch type of the condition. Now beside this, suppose this is over here, this is a figure of the same root which is labeled with its composition, what a different structure cells composes the particular region. It is labeled over here, and in addition at certain places the particular function which the region it performs, that function is also written over here. Now between the xylem bundles and below the phloem, between the xylem and phloem, there is a conjunctive type of tissue. There is a conjunctive type of tissue is over here. This is a conjunctive type of tissue over here. This is a conjunctive type of tissue over here below the phloem bundle. Suppose this is the phloem bundle and this is a conjunctive tissue over here. So this is conjunctive tissue below the phloem bundle and between xylem and phloem. This conjunctive tissue is of parenchymatous type. Now whenever the secondary growth it is to be started, from this conjunctive tissue, this particular conjunctive tissue becomes stimulated, becomes active and meristematically divide. And this meristematically active conjunctive tissue which have became serves as a cambium strip. And from this conjunctive tissue, later on there in the root, the cambium ring is developed. The cambium ring later on brings about the process of secondary growth in the root, and the root it increases in the thickness. So this is conjunctive tissue in the dicot root present below the phloem and between the phloem and xylem bundles. Parenchymatous type of conjunctive tissue serves over here as a cambium, as a meristematic tissue, bringing about increase in the girth of the root by the process of secondary growth. So conjunctive tissue is also present in the dicot root. So this is all about the description of dicotyledonous root. In this particular description, to be as a dicot root, we have to remember the features related to the how many radial vascular bundles are there, what organization they shows, and we discuss as we discuss over here, the total number of vascular bundles in the dicot root varies from 2 to 4 in number, that is from diarch to the tetrarch 4, and the xylem bundle they shows X-arch organization, that is the protoxylem points are present over the X-arch manner. X means outer, arch means the protoxylem points. The protoxylem points are facing away from the pith, away from the center toward the peripheral part, toward the pericycle. The protoxylem points are facing. So this is the X-arch nature of the dicotyledonous root. So with this, we have discussed over here the internal structure of the primary internal structure of the dicotyledonous root, which have cut it in the transverse section. Now, in relation to the internal structure, if you have any doubts, you can ask me the questions on the group. And beside this, for examination purpose, we have to prepare this figure. We have to prepare this sector figure. This is the sector of the root. This figure is enough. The core part is fully sketched, and the peripheral part is sketched by this manner. This is the peripheral part, and this is the complete core part showing all vascular bundles, how many they are present, how they are organized, how they looks, what arrangement, exarch arrangement, how it shows. This is reflected in the internal part of the conducting strand part of the root. So this is all about the internal structure of the dicotyledonous root, showing diarch to tetrarch and exarch nature of vascular bundles internally. If you have any doubts, you can ask me the questions on the group. So with this, I conclude over here about the description of internal structure of the dicot root. Dhanyavad.